So this is a video I've attempted to make 3 times, almost have made 3 times. Here's a pretty much complete 12-volt wiring system for the vehicle. Imagine this is a short wheelbase 1971 Land Rover, and these are the 12-volt wires. The completely redesigned 12-volt wiring system is now in the car. It's also the story, I guess, of a startup and making content around a product that's continually in development. It's really tricky to find that balance between an interesting story, which is, the challenges, the mistakes, the missteps, the problems, how you overcome those, and a marketing video, which is essentially what these are, showing the finished product and what you can expect as a customer. Where that's been really tricky is with the electrics, and not the high voltage stuff so much, because it's big and awkward to fit the batteries, but the wiring is actually quite simple. It's the 12-volt systems, the way the vehicle is controlled, and to me, I guess the human sort of machine interaction, the way the controls work, and we've made a lot of videos about this stuff, but how that all actually comes together in our production vehicles is something that's taken a long time for us to, I guess, get to a point of manufacture, a version 1, let's say. So to start the job of wiring, the first thing is just to figure out what you need. And so that starts with sketches of basically every electrical part in the car. And very roughly, things like the headlights, and that's drawn as, low, high, DRL, park light, that's all one assembly. But need to know just how many cables there are and where they interconnect and all those kinds of things. We've done some fun stuff like integrate a light bar into the car. So adding circuitry that you wouldn't expect to find on these to add functionality, because us running an extra wire for a light bar now is really, really simple, but is a complex thing to do later on. If I cut to some earlier video of young me working on the early jaunt systems, it was thinking that we'll use traditional fuses and relays and we'll rewire the Land Rover, but do it in a more modern way. There's a bunch of stuff that we're doing in the prototype build that won't make their way through into production. They're just not needed. But for right now, they're super important and very, very helpful. So things like putting a label on every single wire that's anywhere in the car, every end of every wire, so that we can cross-reference both the position, the color, but also the number, the code number itself, which then cross-references back to this board, which has, the color of the cable plus its position plus its code number at both the point where it hits the power distribution module and also where it hits the thing that it's ultimately plugging into. Where that quickly transitioned was the amount of complexity that we wanted to add into the vehicle. And I say that complexity to, without sounding naff, deliver simplicity. So how do we make the wiring as simple as possible? How do we make the operation of the vehicle as simple as possible? Well, we actually need to add in what I guess in some ways could be seen as complexity. And that means moving from traditional fuses and relays to computers to control things. This is what's inside the main Junction box. Open the bonnet of our cars, you see this box with the Jaunt logo on it. This is what's going on inside. We'll cut to some overlay of us assembling some of this thing. It's a lot of crimping and wiring and connecting, but the real brains of it are up the front here. And what you can see all these wires going into is a Blackbox PDM. So it's made by an Australian company, and there's lots of variations on this, different brands doing a very, very similar thing. Broadly, there's 30 inputs and 30 outputs, and a main connector to connect power from the 12-volt battery. So inside this is basically a computer system that we can say, hey, when we see, when you flick that switch and we get that input, we'll turn on that output. So flick the headlight switch, turn on the headlights at its simplest. But when you can put that into software, then you can start to do some really smart stuff. Create certain modes that the vehicle's in, listen for other things, have one switch that enables multiple outputs, or one output, a certain factor on that output controlling, switching other outputs, or all kinds of optional information. A temperature signal comes in and that triggers outputs. What does the car do in sleep mode, camp mode, charging? What features are enabled? How do we control temperature and 12-volt battery charging off the main battery? How do we monitor the health of the motor controller? How do we monitor the health of the battery system and communicate that into the driver's passenger compartment, the dashboard? All of those things could be done in with individual relays like these, but it is vastly simpler in the end, once you've done one, if you're doing multiples, to do the work, to write the software, to control that system, and then to be able to just load up the Jaunt subsystem, whatever we're up to, version 14 at the moment internally, and load that into each vehicle and turn it on and know that it works. And that gives us some really, really powerful opportunities. It allows us to add features without added cost, and it allows us to, like I said, integrate really well with some of the other electronics that are going on in here. And importantly, that's things like warning lights on the dashboard. If there's an error in the motor controller or the motor, if there's an error in the battery management system, we can understand that signaling using just CAN bus and things like that are normal automotive practices. But if it wasn't for this, our systems are somewhat standalone and can't holistically connect, which is something you need to do. And again, it's a lot of the work we put in is for these extreme circumstances. So that might be an accident, it might be something going wrong with the batteries, or they're very empty, they're very full, whatever it might be. A lot of those extreme scenarios are where you've got to put in the work and create systems that can handle that and communicate an error or handle an error without needing to alert the driver.
Those really early sketches have turned into proper wiring diagrams. This is the front of the car. So passenger side headlights and indicators, washer bottle, driver's side, and then all the other, fans, coolant pumps, vacuum pumps, horn, all those kinds of things. You can see the modularity built in that I've shown with the connectors themselves, but this is just showing how, what each pin is of the connectors that separate that wing to the main radiator panel and all of that.
I'm talking about stuff that, modern vehicles have been doing for a lot of years, but it's a little bit unusual to be doing something like this in a, EV conversion. But we are, I was going to say lucky enough, we work with old Land Rovers. They need the whole wiring system changed anyway. So when we're doing that, we had the flexibility to have this blank canvas. And when we have that blank canvas, you can think about integrating all this together and doing it well and doing it the way that, rather than piggybacking on systems and more piggybacking and hacking into systems, to build it right from the ground up and build something that ultimately requires a lot less labor. It's a lot easier to diagnose, it's a lot easier to upgrade and add features to, and all the benefits you get from building an integrated system. So all those little things that I talked about, ages ago on that video with Arduino, forward, neutral, reverse control and that kind of stuff, that's 1% of what this does now. And I'll go through the software and show you, some of that functionality. This is the software that configures the PDM, so the power distribution module. So you can see that we've got things like the master on, the vehicle on switch, basically when you turn the key, the charge contactor, reverse, drive profiles, on or off road, horn, lights, cabin lights, hazards. There's not a lot of buttons in one of our cars, but this is kind of all the inputs that it sees from, particularly from the user. There's a bunch more inputs that come via CAN bus, so as a software signal from other bits of equipment in the car, but this is the stuff that you, as a human, can interact with. One of the videos we made that people reference all the time is where I'm working on the little Android sort of prototype control unit. And we quickly realized doing that we were sort of adding on these subsystems to work with different areas of the vehicle. when really we should be thinking about that more holistically. When we're replacing every bit of wiring in the car anyway, how do we do that in the most holistic way that, you know, literally cuts down on the wiring and gives more control to everything that we put in the car? So where that ended up, looking across, you know, all the industries that are sort of connected to us, robotics and motorsport and all of that, is that we needed, you know, the idea of a, you know, I guess often they'll be called ECUs, but essentially we want one computer to be the brain and be the boss of the vehicle, and all the ins and all the outs kind of connected to that thing. And we've got there to an extent. We're really happy with what we're building. In anything in microelectronics, you can always look at anything you do and think, well, in future we could, you know, mash that all together. It could be one printed circuit board. That could be optimized, all of these things. So that can all happen. But in terms of the logic, the way that it's controlling things, the safety systems that it's enabling, the great features that it's enabling, and the flexibility that we have to update things, we're really, really happy with what we've produced here as a version 1 system. Where it gets really, I guess, smart is when we start to look at functions. This is a bit of a confusing, very visual sort of programming language. It's kind of half a programming language. You've got to write things in very much sort of plain English, if statements and or that kind of thing. But with all these things, this is really how the car works. You can see up the top here we've got things starting with VS. That's standing in our language for vehicle state, charging, accessory, running, camp mode, sleep mode. Sleep mode's there too as something that means that this is always awake a little bit, monitoring the systems in the car, making sure that, you know, your 12-volt battery doesn't go flat, looking for other systems, whether that's security or charging or whatever it might be. So there's a little bit of stuff happening, as you'd expect in a modern EV, a little bit of stuff going on and processing all the time. As we get down to it, it's more things that we're talking about, like, you know, the flasher system to make the indicators flash and the demister enable and DRL enable and all of these things. Why do we have them? Well, it's because, you know, say daylight running lights only work in these states, or something like, where's an interesting one, reverse light only works when these conditions are true. And some of these other things get more complex, like, do we get a fault signal from the motor controller and the car is in this state, then deliver a signal onto the dash, or even the way the warning lights do a self-check when the car starts up. So, you know, you turn the key on a car and you think all the lights on the dash come on momentarily. So we do all the self-checks. The lights all come on when you start the car and then turn off again. All of that functionality is in here in what's called functions. Of course they are. Just as a bit of an overview quickly of what's going on here and why there is, while I talk about all this software stuff, there is still physical relays and fuses. There's a few things where we do need to draw more current or have systems that are connected or isolated from this system. So we do things like, this is a bus bar that will be fusing, say this needs a fuse itself. There's other things that want fusing the DC to DC converter back into our 12-volt system wants fusing. But also there's things that are running really high power or high draw, or we want to isolate from the brains here. Now that in one case might be the accessory sockets. So 12-volt power, USB, while this controls the circuit that turns those on or off, the direct power to those is isolated from this unit. There's a fuse here that's accessible without having to pull the whole box apart. It's triggered by a relay. So again, just isolating things to think about what is a likely, I guess, or the most likely worst case scenario. Doesn't mean it's likely, but it means that it could happen. Someone jams a fork into a USB port, what happens? We don't want to fry the car in that scenario. This is the diagram for the battery management and control circuitry within the car. We keep this separate from the other 12-volt systems. We run more insulated cable. We protect this. It is, you know, fundamental to the, you know, operation of the vehicle. And so we can have CAN bus flowing through each battery pack. We have connections for control of the charge systems. We have
triggers for the contactors, the positive and negative in each pack, and we loop through each pack and connect and have this one circuit going all the way through to the charger. Spotlights, indicators, hazards, camp mode, all of those kinds of things. And things in the inside like handbrake switches and stuff that you don't operate but not directly, you sort of do. And those are connected to all the outputs. So a list of the pin order, but all the functions of the outputs. And you can see there's quite a few more of those because we're actually talking to various systems in the car, as well as the things that you would be more conscious of, like headlights or reverse lights or brake lights, and functions around forward and reverse directions of the motor that in the current configuration in a car you can't control, but things that you might want to option on your vehicle and have a little bit different to our standard system. It's already built there to control it. We just have to, perhaps change the graphic on a button to be able to do that. And of course, what this means is that any button could control any function. So any input can be any output or vice versa. And that allows us to configure things differently in the dashboard depending on the customer's requirements. You can see also in the output that we can see the amp draw. So this is not plugged into anything at the moment, so everything's zero. But if you think about a fuse in a car and it's a 5 amp fuse, that's because that device is drawing, at worst 5 amps, and if it goes beyond that, that means the fuse will blow and disable that system. This can be a lot smarter than that, and we can do things. If I look at, say, spotlights, and I can give them a fuse current, so that's essentially me giving it a 20 amp fuse. I can also say, hey, reset it if I want it. So it something triggers that makes it blow. I can actually say, hey, try a few more times and see if it keeps happening. This is currently set to fuse resets allowed, 0, but we can set that to have multiple, resets. If it's a mission critical system, we do things like allow those resets a few times just to check to make sure that it wasn't just an anomaly. The other great thing is that this can understand the idea of what's called, I guess, inrush current. Sometimes you turn something on, say a fan, needs a little bit more power to start spinning up. Once it is spinning, it doesn't draw a lot of power. But we can set a fuse current to be its more constant power, so that lower fuse rating, and allow it to understand that momentarily it might need a little bit more power to get going, but not trip at that. So you can actually build a safer system by looking at the average current draw rather than fusing it for that momentary draw. We also use these relays to isolate the 12-volt circuit, the normal 12-volt circuit, controls, lights, wipers, whatever, from the control circuits of the motor controller. Now, there's noise, there's potential, I guess, isolation issues when you've got a inverter in here. So the motor controller makes its own 12-volt system. This gets pretty nerdy, but basically the battery management system can think that there's a potential connection between the battery and that 12-volt system because it's all happening in the inverter. To completely isolate that and the controls, so throttle, brake, and a few other ins and outs from the motor controller, we isolate that through relays. So there's no direct electrical connection between our normal 12-volt system and our motor controller's 12-volt system. The ability to see this and connect to this and update this is what's really, really powerful. So without having a full-on computer, I guess, it is a computer, right? But if you think about a modern car and the giant screens and all of that, there's a very, very powerful computer behind this. This is really just fusing outputs and controlling some inputs. It's pretty simple. It's absolutely rock solid, and it's been tested in some of the harshest automotive environments. While I have been able to talk about the how of a lot of these processes, so how do we put things together, I guess it's always been important for me to talk about the why as well. Why do we do these things? Why do we put this part in instead of this part? Now, sometimes that's, I guess, quantitative. It's because this is slightly better, this is slightly more heat resistant, this carries this current this way, this is safer, this does this. But often it's about something that's more qualitative in measurement, and that is the harder thing to, I guess, design for. It's the harder thing to
put in a business plan, but it is something that ultimately is what defines the product, whatever product it is that you're making, physical, digital. So all of that software, all of that hardware, all of those wires, all that work is really just to make this go. Maybe that doesn't seem that complex, a few gauges, some switches, some stalks, but that level of complexity and that level of connectedness is what's required to make this feel holistically, feel like a complete car rather than a conversion. So how does it all tie together, and how does it feel like this was always meant to be, not something that's tacked on with a separate gauge or separate switch or very different looking things, or something that doesn't kind of integrate all of the opportunity that this has given us, a giant battery pack in an old Land Rover. So that means things like camp mode, that I can turn that on and you can then plug in your fridge, charge your phone, run the lights, whatever you might want to do, and do that for a month because you've got the biggest battery that you'll ever own inside this car. So it's simple in the end in operation, and that's the goal, but it's enabled by a fair bit of hard work and a lot of mistakes and a lot of changes in direction and changes in hardware choices and a lot of inspiration and a lot of I guess amazing things that we've been able to draw from around the world in lots of different industries to bring this something together that can be produced at a small scale but at a really high quality.